In this optimization problem, we have a rectangular piece of metal that is 30 by 16, and we'll be making it into an open box, which means the box will have no top, by cutting squares out of the corner of the metal and folding up the sides, so that when we're done, our box will look something like this. So it's an open box that has no top. And the dimensions of our box will be 30 minus 2x by 16 minus 2x by just x. And in this problem, we'd like to find the size of the squares to maximize the volume. So the volume of our box will be the 30 minus 2x times 16 minus 2x times x. Or if we expand this a little bit, 480 minus, that'll be 60 minus what? 92x plus 4x squared times x. Or one last time, we'll have 12 or 4x cubed minus 92x squared plus 480x. Since we want to find the the maximum volume, we'll need to consider the derivative, which in this case is 12x squared minus 184x plus 480. Each of these is divisible by 4, so if we factor a 4 out, we'll have 3x squared minus 46x plus 120. And this is going to factor into 3x minus 10 times x minus 12, which means the derivative will equal 0 when x equals 10/3 or when x equals 12. We're looking for a maximum, so I need to do some sign analysis. I need to test what's happening before 10/3, between 10/3 and 12, and after 12. And if I use the number 1, I'll find that I have a positive value before 10/3. If I use the number 5, I'll find that I have a negative value between 10/3 and 12. And if I use the number 15, I'll find that I have a positive value after 12, which means that the maximum occurs at 10/3. So my box, the size squares will be 10/3 of an inch by 10/3 of an inch. And now if I want to find the maximum volume, which is the second part of the question, then I need to find what v of 10/3 is based on my original function up here. So when I plug 10/3 in for x and simplify this down, I get that x is about 725.926 cubic inches. Let's consider another example of optimization. I am 1 mile in the ocean, so here I am swimming. Here I am swimming, and I'm 1 mile out from the shore, and I'd like to get to town, which is 3 miles away from where I am in terms of the shore. So the town's here, and this distance is 3 miles, and I'd like to figure out where for the shore should I swim so that I'll have the minimum amount of time to get to town. I know that I swim at 2 miles per hour, and I can walk at 4 miles per hour. If this distance is x, then my remaining walking distance will be 3 minus x. And since this must be a right triangle, by the Pythagorean theorem, the distance I will swim will be the square root of x squared plus 1. So since distance equals rate times time, that means that time equals distance divided by rate. So my total time will be made up of the time spent swimming and the time spent walking. The time spent swimming will be the distance swimming, in this case the square root of x squared plus 1, divided by my rate, in this case 2. The time spent walking will be the distance 3 minus x, divided by my rate, which is 4. So this is an expression for the total time. The derivative of this, since I want to find a minimum, would be equal to 1/2, because of the constant 1/2 here. The square root of x squared plus 1 is the same thing as x squared plus 1 to the 1/2 power. So when I take its derivative, I need to use the power rule, so I'll bring the 1/2 down. It'll be x squared plus 1 to the negative 1/2, and then I need to take the derivative of the inside, which is 2x, by the chain rule. The derivative of 3 minus x over 4, if I'll think about it as 3/4 minus 1/4 x, would be negative 1/4. Cleaning my derivative up, I end up with x over 2 times x squared plus 1 to the 1/2 power. Right, so I just simplified this, minus 1/4. And I need to find out, since I'm trying to minimize the time, when this equals 0. Well, that will occur when the entire thing is equal to 1/4. And since this is a proportion, I'll cross multiply. So 4x equals 2 times x squared plus 1 to the 1/2. Dividing by 2, 2x equals x squared plus 1 to the 1/2. If I square both sides, 4x squared will equal x squared plus 1, or 3x squared will equal 1. X squared equals 1/3. So x will equal whatever the square root of 1/3 is. I can simplify this a bit to 1 over root 3, which is the same thing as root 3 over 3. So I should swim root 3 over 3 miles from where I am in the ocean, so that I can minimize the amount of time. In the final video on optimization, we'll look at 2 more optimization examples.